folks. It's almost the end, but here we are again. Wanted to take a quick second and give a big thanks to our 2020 sponsors. That's Checkmarks, Google, and Offensive Security. Thank you all so much for helping to make the AppSec Village happen. We could have done it without you. If you haven't gotten your shirt yet, go to appsecvillage.com and pick up your t-shirt. Also, if you're interested in making sure that this is a lasting thing, go out and become a super fan for us. That would go a long way towards helping to make sure that hopefully if next year's DEF CON is in person, AppSec Village will be part of it. Alright, without any further introduction or me talking, we are going to hear a talk from Mehmet Ince, managing partner at Invictus in cyber intelligence. He's going to be talking about a haven for hackers, breaking a web security virtual appliance. With that, please help me welcome to the stage Mehmet.
Let's talk about finding a zero-day vulnerabilities. In that presentation, I'm trying to take you all to the journey with me to finding different vulnerabilities in a security solutions, and combination of them will give us a remote code execution with a root user. This is Mehmet. I've been doing vulnerability researching since 2005, and I'm working for a company, Invictus Cybersecurity and Intelligence. And this is my Twitter address, MDISec, and pentest.blog is a web page where me and my teammates sharing our technical research in here. Okay, so Heaven for Hackers third edition. Actually, there's a story behind of that title, and it has started back in 2017. And I was doing a pen testing for a company, and there was a blue team members, and they were telling me you are doing this, etc., and etc. And I was start thinking about what happens if we somehow manage to break into your SIEM product of that they are using, and write a custom rule in order to become a total invisible. Because they are telling us what they are seeing in the product, and if we become invisible, that would be so nice. So that idea led me to finding a remote code execution on a various different SIEM and the log management solutions back in the 2017. And after 1 year, I was trying to send an email to a friend of mine, and that dude was not receiving any email from me at all. And it turned out that there was a problem on the email security gateways, and they managed to solve the problem. And eventually we started sending an email to each other. And I was thinking that, all right, there is an email security gateway products, and what happens if I manage to break into your email security gateways? So that I can read all the emails incoming and outgoing. So that idea motivates me to finding a zero-day remote code execution vulnerabilities on Symantec, Macrofocus, and the Trend Macro. And previous year, I was working another client, and the project was hardening the client's network in order to finding data exfiltration scenarios. And they were telling me we have the web security solutions, and only that device can connect to the internet. So all the clients has to go through that box. And if you find a different way to exfiltrate the data, that would be nice. And I was like, okay, so what happens if you find another zero-day vulnerability on especially the web security and the content filtering solutions? So when the attacker managed to execute a code on the client network for the data exfiltration and the C2 communication phase, they can exploit the content filtering solution. So this is today's topic. We are going to talk about the zero-day vulnerabilities that I found on a very, very interesting product. And I have a case study for you. there is a product from the Trend Macro, Interscan Web Security Virtual Appliance, and I have done the vulnerability research on specifically that solutions, and we are going to see what kind of vulnerabilities that I managed to find. And using all of those vulnerabilities together, we are going to see some sort of code executions in the end. But before diving into the case study, I would like to a little bit talk about what is the content filtering in order to make it crystal clear to everyone. As you can see in the picture, there is a computers on the left, which represents a client's network of the company. And those devices don't have a direct internet access. They have to go to the proxy service first, and that proxy service goes to the internet so that the organization can do some sort of analysis and the rules on the client's network. So content filtering is happening in here right now. We can imagine that the content filtering solutions, they are kind of spatially implemented proxy service, and that term is given to do controlling the type of web content that employees, guests, customers can access while they are connected to the business wired or wireless network, so that the business may want to apply control over the type of a content that can be accessed to stop employees by restricting, accesses to a certain type of web pages. And on top of that, also the content filtering is a quite a good place to ensure malicious web pages cannot be accessed, such as those used for phishing, malicious, distributing malware, etc., etc. So we are targeting that kind of products in this presentation. So at the beginning, I was like, I have a two main motivation, like a targeting web filter solutions. Why we are doing this? And first and foremost, obviously, all the clients network are going to the internet through that solutions. That means if we manage to break in, we're going to see the whole client's network internet traffic of the organization. And second motivation is, as I told you before, client's computer don't have a network access to the internet. They must go through the web filter. So we need to find a better way to CT communication in the red teaming scenarios. And I believe web filter solutions is a quite secure and stealth way to make a CT communication. Of course, there is a lot of different approach, like a DNS beaconing, etc., etc. But I believe that is a very secure and stealth way. So, all right, that is the brief introduction to the idea and the main motivation. And this is the methodology that I usually follow for my vulnerability research projects. And there is a 7 steps. And we're going to see every single step in details throughout the case study. And first and foremost, we have to find a way to get a free trial of the product that we're going to do vulnerability research on it, because you have to break into operating system level, and you need to find all the source code and etc., and you have to test your vulnerabilities, and eventually you're going to implement the exploit for the vulnerabilities you found. So you have to find a way to get a free trial, and it's not quite easy, guys. Always, it's not quite easy. It's sometimes, and most of the times, it requires to have a lot of meeting with the sales team. And if you find a free trial of the product, I strongly suggest you to start by reading the documentation, because there is administrative documentation of this type of solutions, and there's a huge technical information about the product itself. So after that, we are going to find a way to have a root SSH access to the box, because we are going to do the vulnerability research, and most of the case there is operating level hardening, and we need to get rid of all of those hardening stuff. And after that, you are in a situation where you manage to install the software, the solution, you read the documentation, and you manage to overcome the operating level system hardening. And that is the moment that you need to start using product itself like a regular user, because you have to understand all the features, because those information will come so handy when you need to define a possible attack vector. So After that, we are going to talk about the enumeration and the configuration step. And the most important phase is the defining possible attack vectors, because you got all the information you need. And it is a time to building attack scenarios and then find a vulnerability as a final step. We are going to see every single step throughout our case. And in that case, I mean the Trend Macro Intrascan Web Security Virtual Appliance 6.5 version. You can download it from the vendor web page. So getting a free trial was quite easy, specifically in that case. If you go to the Google and looking for the administrative documentation is an important keyword in here for the Google search, you can directly find the administrator file, which is usually like a 300 pages. I strongly suggest you to read administrative documentation, because you're going to see very, very helpful information about the product. As you can see in here, administrative documentations tells us there is a different modes of the product. It can be transparent breach mode. It can be transparent breach mode with high availability, forward proxy, reverse proxy, ICAP, WCCP, etc., etc. So, and that product can be installed very different modes. And on the right side, you are seeing the forward proxy mode, which tells you, that product can participate in a proxy chains, forward all the traffic to the upstream proxy servers, and you will be seeing lots of graphics on the administrative documentation, which will help you to understand about the product itself. So we are reading the funny manual as well. And we, of course, for the third step, after reading the documentation, you need to install the solution into your virtualization and the visualization system. During the installation, there was an admin user and the password has been set during the installation, and the product gives you an opportunity to do SSH connection to the box with the administrator user. But the problem is there was a restricted shell on the SSH. There is a very, very limited tools that you can use in the SSH interface of the product, and we need to find a way to have a directly SSH connection with a root user, because we are going to do remote debugging. We want to try to find out all the source codes, and we're going to do further analysis, etc., etc. So there's a little bit a step before starting to do vulnerability research. In that case, it was like a quite easy, because the product was distributed by the vendor as an ISO file, so you can directly install it into your VMware or VirtualBox. And when you finish the installation, the idea is you can detach the VM Deka disk from the virtual machine that you just installed, and then you can attach it to the different Linux machine. And then you're going to mount new disk, and you are going to find a graph file, because there was a password protection on the graph file, and I want to get rid of that protection as well. And you just need to remove the password protection line on the graph file. And after that, in order to get rid of the restricted shell thing, you can go to the sht config file and you can enable remote root login. And if you do that, you need to go to the etc pathfeeder file and add beambash for the root user, which will give us a direct SSH connection with a root user without having any restricted shell at all. And we have to undo every single thing that we have done so far. So that means you need to unmount the disk, detach the VM Deka file, and attach it back to the original VM and reboot the machine, actually. And in that case, you are going to have the direct root SSH connection to the box. This is important. We need to get rid of, operating level hardening. So we are kind of ready to start using product itself. In that case, I choose the reverse proxy mode, but I believe all the vulnerabilities that we have found exist no matter what is the installation mode at all. For the fourth step, I strongly suggest you to use a product for a day to get used to about the features itself, because there is a lot of functionality, as you can see in the picture. There is a URL access control, HTTP decryption. We right now we know that product can offload the SSL at all. That means we can deploy SSL through the administrator interface, and there is an advanced threat protection on the left side of the menu. As you can see, I hope you are seeing my mouse pointer in here. There is advanced threat protection. That means all the HTTP or HTTPS traffic will be analyzed by the product in order to find out malicious activities because of that feature. So later of that presentation, guys, we are going to see how important it is to understand and getting familiar with the product interface. Yeah, it's quite important. Just use it like a normal user. So we have a search access with a root user. So the initial step is always enumerating the services. This is what I'm doing. Of course, that will be a better way to do it, but this is my way to do. So I always looking for the nested command to find out what kind of services we have in the product itself. As you can see in here, there is a UWSGI, which listens for 6011. That means, we are doing some sort of assumptions in that phase. So that most probably means there is a Python project running in the internal system. And there is a Java process which listens exact port of the administrator interface. That means we are going to deal with the Java when the time comes to doing a research on the administrator interface. There's another UWSGI in here, and that is another important thing, because as I said before, that product acts as a proxy service. So that must be as some service on the product itself in order to handle incoming HTTP connections from the user. So IWSSD process that you are seeing in here, which listens for 808081. This is responsible for all the incoming connection from the client's network. So this is the majority part of the product itself, because that is the one who is communicating with the clients. All right, so those are the services that we have in the product, but we need to find which of those services are allowed to communicate with the different computers in the network, because in the end we need to exploit at least one of those services. So what I'm doing to find out that information, I usually run an mmap scan from my main host to the product IP address, or you can just use the IP table / list command to find out, the IP tables rules. So according to that rule, most of the internal services has been forbidden, to network traffic from the outside of the machine. You guys are remembering, the IWSGI service, if you keep doing enumeration, we are seeing very interesting information in here. As you can see in here, there is a supervisor D which is responsible for starting the Solr service. So right now we know there is Apache Solr and lots of Python services in the box. So what is Apache Solr? It is an open source enterprise search platform written in Java. Its a major feature include the full text search, highlighting the time indexing, dynamic clustering, etc., etc. So that means that Python project that we are seeing in here is responsible reading and writing the log file into the Apache Solr service. So most probably, whenever the request comes to the proxy service from the client's network, that proxy service is sending some sort of signals to the Python project that we have seen in here. It's something like a internal microservice. So that Python project is taking the information and writing it into the Apache Solr service. So whenever the administrator user try to query something through the administrator interface, that request will be coming to the Python project as well, because the naming convention in here says the dashboard parse, mains, stats parse, summary parse. There's a lot of log parsing and writing to this Apache Solr service, and whenever it needs to be the access by the administrator interface, and that Python project is taking the responsibility again. So it is quite important to know there is an Apache Solr service within the box, but unfortunately, due to the IP tables rule that we have in here, we're not going to be able to directly communicate with Apache Solr at the beginning, but later of the presentation, we will find a way to do it. So, all right, let's talk about the IWSSD process. If you grab it from the process tree, you are seeing the full path of the binary. And if you look for the file type, it is a symbolic link to the IWSS process, which is SUID LFI binary. And there is a 61 module in that binary. So it is a very huge binary, and we can, of course, target that process, but it will be requiring lots of reverse engineering. So, of course, we are going to do that at some point. But one of the most important attack surface, as you can imagine, it is a proxy service itself. So far, I believe I just spent 20 minutes, I guess, and we managed to collect enough level of information about product itself. So it is time to define attack vectors in a light of those information that we got so far. So we know that administrator interface is written with Java, and there is a proxy service which is written with C++. I haven't told that before, but it is a C++, guys. It's my bad, sorry. And there is a lot of internal services, but most of them are not accessible from outside of the box. And you guys are remembering, SSL decryption and advanced threat protection features of the administrator interface. So we know that it does offloading the SSL, it parses HTML content, scan files, etc., etc. So my idea at that phase, was, okay, let's start with the administrator interface, and we can go after proxy service if it needs to be, let's start with the administrator interface at the beginning. But there is a lot of possible attack scenarios, as you can imagine, one of the, if you want to, let's say, target the HTML parser of the product, like a browser exploitation, you can just send a phishing email to the one of the employees of the company that contains a link. Whenever the user clicks on that link, that request will be sent to the proxy service, and proxy service is going to take that request from the client, and it's going to send exactly the same request to the destination server, which is a web page that attacker can control. And whenever the proxy service gets the response, it performs analysis. It has to parse HTML content and scan the file. So that means you can directly attack to the HTML parser engine of the product. There is a lot of different possible attack vectors. That was just one example that just popped in my mind right now during the presentation. But and we are going to talk about the administrator interface, and then we're going to talk about the proxy service. As you know, it is a Java project, and I like to working on the Java project. And every single time, whenever I facing with a Java application, I always start by reading the configuration file, because the web.xml, stress.xml, all of those XML files contains a very good high level of understanding information about the software that we are going to do vulnerability research. And I don't want to live in an SSH connection during vulnerability research. So we need to find out all the location of the jar file by using just find command on the step 2. And then you can copy all of them to your main host to further analysis, because we are going to deal with lots of jar files. And I strongly suggest you to use IDEs. Yeah, I used to use GDGUI for the decompiling or the jar files, but those kind of project has hundreds of different jar files, and if you put all of those jar files into the GDGUI, it wasn't working for me. It was just crashing or freezing because it has to decompile all the class and the functions, and they need to find all the cross calls. So I strongly suggest you to use IntelliJ or Eclipse for that purpose. And if you are up to use the IntelliJ IDE, there is a Java the compiler.jar file under the compiler library, which comes by default with IntelliJ, I guess. And you can compile all the jar files under the lib folder. You can change the name, of course, and we are going to put all the decompiled files under the lib-decompile folder. And if you go to the IntelliJ interface and look for the project settings, there is a library section in here. You can import those libraries and sources all together, which will tell the IntelliJ to this is my Java software, and IntelliJ will take the rest of the job. It's gonna process all the classes, and you're gonna be able to just finding a function that you are interested, and you will be just clicking it to go to the definition. And also you can find a very interesting function that might be some problem in the definition. You can just by using the IDEs, you can find all the different locations where the specific that function has been called. So I strongly suggest you to be a friend with IntelliJ or Eclipse if you are up to vulnerability research on Java application, guys. So I beg your pardon. So we have an access to the source code of the administrator interface. So we are ready to do for the last step, which was finding a vulnerability. There is a different approach to do it, like top to bottom or bottom to top. Bottom to top means the potentially vulnerable functions on the Java, let's say, and you can directly search those functions within the code base. And if you believe that you just find a very interesting, very insecure way to use those potential vulnerable function, you can start from the bottom to go to the top in order to find out whether you are control to parameter that pass through all the function calls. Or you can start from top to bottom, which is like, start by reading the filter or the middleware definitions and the classes, look for the authentication mechanism, and then search for all the controller or the request handler definition, which will be important because that is the location where you can see the user controller parameters, etc., etc. In that case, I was doing top to bottom approach. I choose that approach because of not very specific reason. I was like, doing funny time on the Sunday, and I was just start reading the source code, and it was like a top to bottom approach. I wish I could show you all the code bases and everything, but I believe I don't have enough time to do it. So I just grab a very specific function definition, which named is a mount device. It has to be a post request to be able to execute the function definition. And there is a very interesting if statement in here. It tells you if the request is coming from the local host, it is okay. But if the request is not coming from the local host, I'm going to validate your session and your privilege as well. Since we don't have the username, the password, this is going to be a problem for us because it is a password protections if the request is not coming from the local host. And there is one function call in here, get token, which will be have a very important role on our exploitation. We will come back in later. So that was the important part of the function, and we are moving to the more important stuff. So it tells us that the request must be a post request, and the post body, it is taken from the request, and it is a JSON object. And we're gonna get the one device string from the JSON data. And that part is quite interesting because it performs some sort of escaping. So if the mount device contains a double quote, it will be escaped. If it contains a backtick, $, it will be escaped by the backslash. But the problem is, if it contains backslash, it will escape backslash one more time. So if we have the double quote, it will be escaped one time, and it will be escaping backslash one more time in here. There is some sort of problem in here. And after that, there is a function call, which is a isValid mount device, and it takes our parameter that we can control. And if we manage to pass that if statement, we are going to see exaui helper CMD, which is tend to execute operating system command with a parameter that we are control. So we need to skip that if statement. It has to be returned true. So let's have a look at that one. isValid mount device, it is just like a very weak blacklisting. It tells you it cannot be contained bash, binsh, python, /perl, python, etc., etc. It validates, it performs some sort of blacklisting on that one. But the problem is, it has the white space at the beginning of the Perl and the Python command in here. So it's a very weak blacklisting. We can bypass that without having any problem. So we have to keep that in our minds if we've managed to find a vulnerability. So, all right, we can pass that part and we can reach in here. So it is time to read the exaui helper CMD. And exaui helper CMD, it is going to execute UI helper binary with a sub CMD, which is a command that we can control. So what is UI helper? It is a located in here, and it has a root privilege, and there is SUID bit. So all the commands will be executed with a root user. So if you find a way to execute our command, that command will be executed with the root privileges, which is something very, very important for us. And finally, that function calls exacmd, which is basically calls runtime.getRuntime.exec. So obviously we have command injection vulnerability in here. So when we believe that we have the vulnerability in here, and we need to do the proof of concept. Thanks to the reading of fundamental and the product feature steps of the methodology, we know where is which administrator interface, which many of them it is going to execute that specific endpoint. Of course, you can build it from scratch, but this is more easier for me. And as you can see, that is the post request, and there is a mount device, and we can inject our command in here because the $, will be used for the execution, and the $, escape one time, and the backslash escape one more time, which means there is no escaping at all. That backslash escaping did another one, and there is nothing related with the $, which will helping us to inject our command. So basically, we are executing sleep command with a 15 seconds with the administrator with a root privilege. So let's talk about the exploitation of that vulnerability as well. I'm one of the Metasploit contributors, and I usually using the Python dropper for the exploitation when I especially exploiting the Linux machines. But there's one problem about the Python dropper from the MSF Venom of the Metasploit. It has to be include the double code that wraps up our dropper command in order to pass it to the Python process. So that means we're not going to be able to directly use it because, as you know, the double quotes has been escaped on the backend service. So the idea is that we can use Perl because Perl can take a parameter with a single quote, which is allowed to use. And basically, the idea is simple. I want to execute Python dropper, but I'm gonna put that Python command into the Perl command. So basically, during the exploitation, we are going to execute Perl, which is going to execute first step of the Python wrapper. When the Python executed, it communicates with the handler, and the handler sends the second stage. So there is a lots of execution one and after, and there is a Ruby code, as you can see in here, that we can build a Perl command, which contains our Python command. So it's a quite nice trick. So I reported that vulnerabilities to the ZDI, and of course, ZDI told me that the authentication is required to exploit that vulnerability, but we are going to see that the exploitation can be bypassed, guys. So we have to bypass authentication. Those are the initial ideas. We can find a stored cross-site scripting vulnerability because we can force the authenticated user to send HTTP request to the mount device endpoint where we have the command injection. And since the user going to be manipulated by JavaScript, that request will be sent to the endpoint with the authenticated user. So we don't have to be thinking about the authentication request, authentication stuff. And another idea is it would be handy to find something SSRF-ish vulnerability, some type of SSRF vulnerability could be handy in order to communicate with internal services so that we can send a request from the localhost to the endpoint, or we can go directly after the authentication bypass. I don't have too much time. I'm just gonna show you how I find the stored cross-site scripting on the administrator interface. So as you can see in here, that is a very basic HTTP request to the proxy service. It tells to the proxy service that I'm gonna, that I want to send a GET request to the pentest.below, and proxy service does the job and sends the response back to the user. So that activities is been written into the administrator interface. Guys, remember the Python and the Apache Solr stuff that we have talked 15 minutes ago. That activities has been written to the Apache Solr database, which is represented into the administrator interface. So the idea is that we can control that data in here because we can tell anything we want to the proxy service. So the idea is quite simple. As an attacker, we are going to intentionally download a very, very known malware through the proxy service. So proxy product can detect it and produce a log file, and it will be like, ringing all the alarms, I caught a malware, etc., etc. But that data will be written into the Apache Solr, which is being used in the administrator interface and very, very specifically in here. So when the system administrator logs in and checks what's happening, we can execute JavaScript code on the system administrator browser. And thanks to that JavaScript code, we can send an IX request to the vulnerable endpoint that we have found in the first place. So, there was a quite interesting XSS vulnerability because whenever the browser is sending requests to the proxy, they are performing the full URL encoding in here. But I'm manually crafting the HTTP request to the proxy service. That means there will be a no encoding, and that data is not being encoded on the administrator interface. Basically, we have a cross-site scripting, spatially stored cross-site scripting vulnerability in here. So instead of popping up alert bugs, we can just call IX request to the endpoint that we have the command injection. So I reported that vulnerability to the ZDI as well. And as you can see in the vulnerability description, attacker can leverage this in a conjunction with other vulnerabilities to execute code in the context of the root user. But guys, cross-site scripting is cool. I'm not underestimating any kind of vulnerabilities, but it is just not enough for me because there is a huge setback which requires the user interaction for the exploitation. I was like, okay, I just find something very cool, intentional downloading of malware, etc., etc. That idea was simple and cool, but I need to find a better way to continue the exploitation. But you know, I got another idea while I was spending a time to find the access through the proxy service. So the idea is targeting proxy service itself. So as you can remember from the previous slides, that is the HTTP request, a very simple HTTP request to the proxy service itself. It tells the proxy service that I want to communicate with the pentest.blog. Proxy service sends the request, get the response, and sends back to the user, right? So what happens if I tell the proxy service that I want you to communicate with yourself? In that case, it told me there is a self-referential request to proxy are forbidden, and I was like, all right, that means there is some sort of controls and lots of if statements in the proxy service itself. What happens if I manage to trick the proxy service to communicate with an internal service? That was the main idea. So that is the function get end user order notification function. I set a breakpoint in here, which produced exactly same error message that we have seen in here. And I just sent the same request and it hit the breakpoint and it tells you that get user notification or the notification has been called by the prepare proxy loop rejection, which has been called by the handle proxy loop, which has been called by the due processing. So we're going to read all of those functions. So within the due processing, there is a one function call, which is a easy-reverse proxy, and the function is a member of the HTTP proxy config cache. So basically, product try to understand, like, am I being placed as a reverse proxy? And in that case, handle proxy loop has been called, this function that we have seen on the previous slide. And that function calls TM socket address is same ADDR. That is the important part because that function performs full URL comparison with a URL of the proxy service with a URL of the user try to communicate. So if it is a same address, it calls prepare proxy loop rejection call, and we are seeing that error message. So I just changed the port number to the Apache Solr service. And due to that changes, there will be a no match in the full URL comparison on the proxy service. And there is an administrator interface of the Apache Solr service. And I'm just can communicate with it because of a very interesting bug in the proxy service. So as you can see in here, I'm allowed to communicate with the Apache Solr Service Administrator interface. So, all right, that was another very, very, very important vulnerability because we are going to leverage this vulnerability to the bypass authentication on the systems. And in the end, we're going to chain all of them together, guys. So Apache Solr service in the box, I mean, in the product was very old version because it's not quite easy to upgrade your third-party dependencies like Apache Solr or database servers. And in these type of solutions, it's quite hard to upgrade to newer versions. So there was a very, very old vulnerability in Apache Solr service, but it is exactly what I need. It is an arbitrary file read vulnerability. So that is the name of the collection, and there is a replication endpoint, and the command has to be file content, and you can traverse back to the root folder, and then you can call whatever you want, and that will gives you to reading any content of the file. So at the beginning, there was no way to communicate with the Apache Solr service, but we find a very interesting bug. And by exploiting that bug, we are going to read anything we want. So far, so good. I want you to rewind the get token function. You know, it was like a way behind of our presentation. Guys, all right. Do you remember that get token function? It is going to help us what we are going to achieve in here. Because, because that function takes cookies from the HTTP request and it returns the value. But the problem is it's print out the value and the name of the cookies. But the Java application is running by the Tomcat process. So those standard outputs data will be written into the log file, which is a Catalina.out file. So due to that little function, all of those valid session IDs written into the log file, and we have arbitrary file read vulnerability. So what we are going to do that, we're going to exploit two vulnerabilities together in order to get the content of the Catalina.out file, which contains the valid session IDs. And then we are going to collect all the session IDs together, and we can go to administrator interface in order to exploit command injection vulnerability with the active session IDs. So the idea is actually quite simple, guys. We are going to, in the first step, we are going to exploit a comparison bug in the proxy service, which help us to communicate with the Apache Solr service that is running within the product itself. And this is a very old software which has a vulnerability, and it is arbitrary file reads. And combination of that vulnerability, we are going to read Catalina.out file. And we're gonna, by using regex, we're gonna extract all the session IDs that we have. And there is a check session endpoint. I haven't talked about it because it was quite easy. There is a check session endpoint in the product. We are going to test all the session IDs we have in order to find out whether it is still active or not. And if you find an active session, we are going to exploit the command injection vulnerability, and we are going to be executing operating system command with a root privilege, which will give us a C2 reverse shell to our command and control server. That is the idea. And of course, I have implemented a Metasploit module that performs all of those steps automatically. And I have a video for it. I would like to, I guess, yeah, time is good. I guess I still have a minute. So let's see. And by the way, that Metasploit module has been merged to the master branch of the Metasploit project. You are just, can go and fetch the module and install the product on your lab and, have fun. So when we run, as you can see in here, it exploits reverse proxy service and extract the Catalina.out file. And there was, of course, this is a demonstration. There's only one session IDs in the log file, and it's inactive. And by using that session IDs, it goes to the command injection vulnerability and it executes operating system command, which is a Perl command. Perl command contains a Python command, and all of those steps has been automatically done. And as you can see in here, we have a root session on the web filter solution of the company, guys. That's it. Thank you very much.